Welcome and hello. This is a video lesson in the FHWA hydraulic toolbox. In this lesson, we'll be talking about the bridge scour calculator, specifically preparing a geometry in HEC-RAS. So in the previous lesson, lesson 19, that was sort of a bridge scour calculator introduction. And one thing that I realized I need to explain with a little bit more detail and dedicate its own specific lesson to is to go to the bridge calculator. And then after clicking this checkbox for Enable Scour Plot Options, importing the HEC-RAS geometry, click on Import, navigate to the HEC-RAS.prj project file, and then define some data. So the whole process of creating a geometry in HEC-RAS and really a whole model, which is what I'm going to be doing in this lesson, I felt justified having its own separate lesson and video. All right, so let's go ahead and get started. Just taking a quick step back here. We're talking about the bridge scour calculator in the FHWA hydraulic toolbox. I already have one added right here. It's called bridge scour. Again, if you need to get back up to speed on bridge scour in general, check out lesson 19. I'll go ahead and link that in the notes in the description, and then you can come back here after watching that. All right, so let's go ahead and get started. Like I mentioned, bridge scour analysis, and then check this checkbox. And then when we click import, now we need to click on browse and navigate to our HEC-RAS.prj file. This file is going to contain our geometry for the river or the channel, as well as the bridge data. That's going to be the bridge deck or roadway, as well as any piers and abutments. Okay, so let's go ahead and close that up. We're going to spend most of this lesson over in HEC-RAS and then finally finish things up back in the bridge scour calculator. So I'll just go ahead and close this. The first step is to download HEC-RAS. This is the download page. I'll leave a link to this in the description as well. If that link doesn't work for whatever reason, just go to Google, type in HEC-RAS download, and then boom, it's your first link right here. The most recent stable version at the time of this recording, 6.7 Beta 4a is available, but 6.6 is the last stable version. So I just go ahead and click download. I'm not going to show you how to download it. Once you get that up and running, it should look like this right here. So this is the main file interface. I'm going to minimize for the time being. All right, so to get started, we'll go to File, New Project. Going to navigate where on your computer you want to save this project. So give me just a moment. I'm going to navigate to Lesson 20 and then Project and then HEC-RAS 6.6. I'm going to name the project just Project and then click OK and then click OK. All right, so this right here is the path to my .prj file. Before we can link to it in the FHWA hydraulic calculator for bridge scour, we need to actually build out our model. So I'm going to click on Edit Geometric Data. Down here in the Geometric Data Editor, it already starts me off with one geometric data file. So I'm going to click on River Reach, sketch upstream to downstream, and then just double click, give that river reach a name. We'll call it River A, Reach 1. Also, by the way, I'm not going to be explaining hardly any details with regard to HEC-RAS. What I'm trying to do is just rapid fire through this process. If you have any questions about HEC-RAS, that's a whole nother topic and whole nother software. And you're welcome to ask questions in the comments, but I'll probably refer you to a different video. All right, so we have our reach sketched in. Now I'm going to click on cross section and then click on options, add a new cross section. I'm going to start from the bottom of the reach and just say River Station 0 is the location of my first cross section. At this point, you're welcome to type in station elevation data to define that cross section. I already have it saved on my clipboard, so I'm just going to highlight some fields here, Control V to paste. The downstream distance will be 0. The Manning's end value also is 0.035 for the main channel and 0.05 for the left and right overbanks. And then the main channel bank stations, I'm just looking at my numbers here. It looks like it's going to be 40 and 110. I'll click Apply Data. Now over here on the right, I have a preview of that cross section. If you don't see this, then you can just toggle it on and off with this button here. Okay, I'm going to add a few more cross sections now upstream of this one at River Station 0. So I'm going to go Options, Copy Current Cross Section. Let's do, how about 200 feet difference? So this is 200 feet upstream. Click OK, then change the downstream distance to 200 feet. And the last thing I need to do is go to Options, Adjust Elevation, and then I'm going to add, how about 0.2 2 feet to all of the data points in that cross section. Okay, apply. I'm going to do that a couple more times. So I'm going to have another cross section. This one's going to be at river station 400. Okay, options, adjust elevation, 0.2. Okay, one last cross section. This is going to be at river station 600 now. So I'll type 600 for the river station. Same river, same reach. And then again, I'm going to increase the elevation again by 0.2. So that will be a 2% slope. I can confirm what that looks like by going up to plot profile. All right, so there we go. River station 600 flows downstream to river station 0. And then if I close the cross-section data editor, I have my 4 cross-sections on my river reach. Before I forget, I'm going to save the geometry. So I'll go File, Save Geometric Data, and then I'll just say base, sort of like a base case. Okay, so that's saved up here. In the main interface, I have the word base. That's the title of the geometry I'm editing. And then here is the .g01 geometry file. All right, next what we have to do is add a bridge. So if I go to bridge/culvert, what I'm going to do is add a bridge right here between river stations 200 and 400. And I'll say it's 100 feet wide. So basically it's centered on 300, but the upstream edge of that bridge face will be at 350. The downstream edge of that bridge face will be at 250. Options, add a new bridge or culvert. I'm going to call it 300. Okay. Next, I'm going to edit the deck/roadway. And then after that, add piers. And then after that, add sloping abutments on both the left and right side. So without further ado, I'll click on deck/roadway. The distance downstream from the next upstream most edge of the bridge is going to be a distance of 50 feet. So I'll type in 50 right here. The width of the bridge is 100. I already said that. And then the upstream station data is going to be from 0 to 150. I'm going to copy that same data to the downstream side. And I'll use a 3-to-1 side slope embankment both on upstream and downstream. I told you this was going to be quick, and sorry for not giving you any more details, but we should see that appear in our display. Okay, so there is the roadway. Next, what I want to do is add a few piers, one in the left overbank, one in the main channel, one in the right overbank. So click on pier, and then here I'll move this right here. The center line is for the left overbank will be 30, so we'll type 30 and 30. And then the pier width and elevation will be 4-foot width from 230 up to 250, and then copy to downstream. That's all done. That's the pier in the left overbank. We'll see it appear in just a moment. So I'll click on copy. I'm now editing pier 2. This is going to be centered. So I'll say 75 is the upstream and downstream station. Copy one more time, except this is the pier in the right overbank. That'll be at cross-section station 120. All right, so I clicked OK. Boom, there are my 3 piers. Last we need to do is add a sloping abutment on the far left and far right side of our bridge, both for the upstream and downstream cross sections. So to do that, I'll click on sloping abutment. And then, yes, we're already starting with number 1. I'll call that the left side. And then just paste in some data that I already have saved, copy to downstream, and then copy. Now I'm on the right side. This is the right sloping abutment. Paste in that data I already had prepared, copy the upstream to downstream, and then click OK. So now what we're seeing here is the abutment on the left side and the right side. So I'm going to go and exit out of this, go File, save the geometry data. Now in the plan view, you can see here is our bridge crossing. It's 100 feet wide. And at this point, you may think we're done. Let me go ahead and save the project. But one snag that I ran into is I wasn't able to actually connect the geometry to my bridge scour calculator until I actually set up a plan and a flow file and ran the model. So I'll show you what I'm talking about. So right now, if I click on the checkbox to enable scour plot options, import geometry from HEC-RAS, click on import, and then click on browse. Right now I need to navigate to that .prj file. Let me go down to lesson 20, project, HEC-RAS. Here's the file right here, project.prj. And then the problem is I'm not getting any data. I'm not seeing my cross sections or my bridge, which I know I have defined in that geometry. Even if I click on read file, I'm just getting nothing right here. So that's frustrating. So let's go ahead and do the second half of the work in HEC-RAS now. I'm going to, again, minimize the bridge scour calculator. To make it as simple as possible, I'm just going to run a steady flow simulation. So first I need to edit some flow data. Edit steady flow data. For the boundary conditions, I'll set a downstream boundary condition using normal depth, and we know it is 1% slope. Okay, okay. And then for the flow profile, doesn't really matter. I'll say 100 CFS. And then we need to save this flow file. So file, save flow. I'll just call it base again. Okay, that's done. Now let's go ahead and run it. So we need to create a plan. I'll go up to run, steady flow analysis. We already have the geometry and the flow file saved and ready to go. So I'll save this as a plan. Again, I'll call it base. For the short ID, I'll call that base. We'll assume subcritical and then click on compute. Okay, so that's running and it looks like it's complete. I'll click close. And now one thing I want to do real quick is just confirm that we do indeed have a crude number less than 1 to confirm that the assumption of subcritical flow is correct. Profile summary table, crude number 0.26, 0.26, 0.31, and 0.72. Okay, just confirm that we're looking good. That should be all we have to do in HEC-RAS. So file and save project. Let's go back to the calculator here for bridge scour. One last time, hopefully this will work. Check for the enable scour plot options, import geometry from HEC-RAS, click on browse, and thankfully I don't have to navigate, I'm already in the right spot. Project.prj, and this time indeed I do have my cross sections to choose from. The approach cross section will be at River Station 600. And then if I wanted to actually view that cross section, I can click on view, click on define, and then click on plot. Here's the cross section at River Station 600 that we defined over in HEC-RAS. This should look familiar. Not only do we see the ground elevation, but we also see the Manning's end value in this red line, which is 0.05 in the overbanks and 0.035 down here in the main channel. All right, so let me close those up. We also have confirmation that the number of points associated with that cross section is 8 right here, the number 8. All right, the next one down is the cross section at the bridge. We'll use the cross section at River Station 400 for that. And then finally, the bridge right here. This is at Station 300. And once we make that selection, we have a few more things to check, such as our left and right abutments, as well as the piers. The piers look like they're already done. So for instance, I have 3 piers. They are at cross section Station 30, 75, and 120. If I wanted to view this left here, this is the one in the left overbank. I'll just click on view. It shows me here's my data. The pier width is 4 feet at the bottom and then at the top. This is the base elevation, and then 250 is the top of the pier, which is the bottom chord of the roadway. All right, as for the abutments, we have a left and right. Left has the lower cross section stationing number, which I believe is 0 right here, and then 1 for the right. To confirm, I'm just going to click on the view button and we can see, yes, we have lower cross-section stationing number associated with the left abutment, which means the right abutment should have numbers closer to 150. And there they are. Okay, so that is that. I'm going to close that up. We've completed that step to upload a .prj file, a HEC-RAS project file, which had a geometry, which we defined as part of our preparation to compute bridge scour using the FHWA hydraulic toolbox.